as well. It's really important that you check your graphs on your calculators because on a test, I'm not going to ask you to graph. Why? Because you have graphing calculators. I will always ask you things like what's the amplitude, what's the period, what's the midline, what's the highest value, what's the range, how long is the range? Like I will ask you questions about the graph because you can graph them all on your calculators, okay? So looking at this graph, first I want to know what is the midline? 1. That means our graph was shifted up 1. So when I go to make this sketch, I'm not on the x-axis anymore. I've been shifted up 1. So I'm going to label that just as a 1. I'm going to use a dotted line to represent my midline. What's the amplitude? 2. Very good. The absolute value of -2 is 2. So the amplitude is 2, meaning the distance between my midline and my highest value is 2 units. So how high does this go? 3. Very good. The distance between my midline and my lowest value is 2 units. So how low does it go? -1. So these distances represent the amplitude. 2 above and 2 below midline. Does that make sense to you? Okay. We are graphing a normal sine graph that has been reflected. What was the normal sine song? Middle, high, middle, low, middle. But we're going to reflect it. So what does it become? Middle, low, middle, high, middle. Okay. Let's see, we're starting at 0 and ending at 2 pi. Halfway is pi. Half again is pi divided by 2. And 3 pi divided by 2 gives us my 5 key values. And now I can sing my sine song. Midline, low value, midline, high value, midline, middle, low, middle, high, middle. Those are in the minor key. Okay. Now I want these key points because they're also really wonderful to check on your calculators. Our domain goes from negative to positive infinity. What's the range? -1, 2, 3. Yes, our lowest value is -1. Our highest value is 3. Now, you want to check these on your calculator, so I encourage you to check a point, not the beginning and not the end, but a point in between. What is the ordered pair of this point? 3 pi over 2 and 3. Can I check that point using trace? Yes, I can. So in my calculator, we're going to go back to y equals. We're going to type in our function. -2 sine of x plus 1. And we're going to graph it. If you really want to do something interesting, you could change your window so that it exactly matches your graph. So I want my x-axis to go from 0 to 2 pi. So I could literally type in 0 to 2 pi. Can leave this step where it is, that's fine. I want my y minimum to be -1 and my y maximum to be 3. So you can change your window so that it exactly matches what you've graphed by hand. And then when you graph your function, it looks the same, doesn't it? That's pretty cool, right? Now, we can check this point using trace. So I'm just going to use trace, and I'm going to type in my x value of 3 pi over 2. So 3 pi over 2. Enter. Whoops, wrong button. And I get 3 for my output. I can also see Tinkerbell right there, right at the high point of my graph. So we know we graphed it perfectly. Okay? Do you have questions for me?